Now we will talk about the probability mass functions, the PMFs. A probability mass function is one way to describe the distribution of a discrete random variable. In particular, a PMF summarizes two things. The first is summarize the possible values of the random variable. The set of all possible values the random variable can take is called the range or the support of the random variable. And also, the PMF summarizes how likely they are. So, how to state the PMF? There are several ways a PMF might be a state. For example, we are going to see two of them, the two more common. The first is going to do a table of values. So here we plot we put their numerical value x, and here we plot the probabilities that the random variable take those values. So if, for example, we have the values 0, 1, 2, and 3, as in the previous example, we are going to plot the probabilities over here. What is the probability of x taking the value 0 is going to be 1 over 8. Probability of taking the value 1 is 3 over 8, and so on. Also, we can plot the PMF as a function, as a pairwise function. So for example, we have the value, the PMF is going to be a function, and it's going to be 1 over 8 if x is going to be 1 or 3, and 3 over 8 if x is equal to 1 and 2. Sorry, here is it's going to be equal to 0 or 3, these two cases, and is 3 over 8 if x is equal to 1 or 2, and 0 otherwise. So we have these two possible ways we can state the PMF. So this probability here is going to be the probability of the random variable x taking the value x. How to visualize the PMF? Well, we have here in the x-axis, we are going to plot the values for the random variable x in this case, and in the y-axis, we are going to plot the probabilities. So if we have the value 0 over here, and we have the probabilities to be, let's say this is going to be 1 over 8, this is going to be 2 over 8, and this is 3 over 8. So the probability is going to be in 0. We plot this function with this point over here indicating that the probability is 1 over 8. In 1, this is going to be 3 over 8, so it's going to be over here, and this point indicates that the probability is 3 over 8. And 2 is the same, and in 3 we have 1 over 8. For the next numbers, we can have that this is 4 or 5. For the rest are 0. As it's the random variable range over all possible values, the events, the random variable taking that particular value x, from a partition of the sample space. It then follows from the axioms of probabilities that the probability of the random variable being in T is the sum of all the possible values that belongs to T and the probability that the random variable takes those values, those particular values. And also the most important characteristic is that the sum of all the possible values, summing over all the possible values, the probabilities is going to be 1. Okay, remember that the notation that we are using is that probability of the random variable taking its values is the PMF function of the random variable x in the particular value x. Consider this example. If x is the number of tails out of 3 flips, or out of 3 fair cone flips, what is the probability of x being equal or greater than 2? Well, the probability of x being greater or equal than 2 is the probability of x being equal to 2 or x equal to 3. And these two events are disjoint. So this is the probability of x equal to 2 plus the probability of x equal to 3. And what is the probability of x equal to 2? Where we have both in the, we can use the visualization or the table of values, and it's 3 over 8. Is 3 over 8 plus 3 over 8. No, plus 1 over 8. And this is going to be 4 over 8, and this is 1.5 or 0.5. There is another way to solve this, and it's going to be using the complement. We can use this, or we can use the complement. The probability of x being greater or equal than 0 is also 1 minus the probability of the complement of this event being greater or equal than 2. The complement in this case, if we are considering the x that are, let's say we have x over here and we have the number 2, we are considering the numbers that are greater or equal than 2. The complement is going to be the numbers that are less than 2, not including the number 2, because the number 2 is in this event. So the complement is going to be the probability of x less than 2. And when we have x less than 2, in this case we are using just discrete numbers. So less than 2 is going to be the number 1 and the number 0. So this is going to be minus the probability of x being equal to 1 plus the probability of x equal to 0. And this is 1 minus the probability of x equal to 1 was 3 over 8 plus 1 over 8. And this is 1 minus 4 over 8. And this is 1 over 2, 0.5. So we can solve the problem either directly or using the complement. In some cases, using the complement is easier, so you have to keep that in mind.